Yep, we should be good.
Okay. Uh,
Looks like my sharing preferences are a little off, so a moment.
okay.
There we go. Is that better?
Yeah, that's at least for me, it seems to be working.
Perfect.
Hey, Troy.
Yeah, Brian.
The Google Doc needs permissions changed.
Yeah, I was just going to do that now.
Thanks.
Hello from Santa Barbara, California. I will let all of you East Coasters know that you can thank us for your beautiful sunsets over the past couple of days.
I hope all is well out there. Or as can be expected.
So I think Troy is getting things situated with the Google Doc. Maybe that's already fixed. If you're still having any trouble with that, let us know in the chat. But I think otherwise, Alex, we're ready for you whenever you're ready to start.
Okay. Is my audio and everything coming through fine?
Yep, sounds great.
Awesome. Well, welcome everyone, and thanks for coming. I'm Alex Younts. I'm Purdue University's Principal Engineer for Research Computing. We are inside of the central IT organization here at Purdue, and we focus on providing our faculty all of their needs as they do their research. And today, I'll be giving you an overview of sort of the three big HPC file systems and our experience at Purdue deploying and running these in production. So if you don't know much about Purdue's research computing and our activities, over the last 15 years or so, we have deployed 11 condo models, condo compute clusters. We call them community clusters, starting back with a gigabit cluster in 2008. Our first petascale system was Conte in 2013. We got into the GPU game in earnest in 2019, and we are implementing a 500 node AMD Rome system called Bell right now. It's in early user access. And in 2021, we will be providing the Anvil supercomputer on Exceed. On top of this, we run a fairly large science DMZ. We just called it the Research Network. We have multiple 100 gigabit peerings out into the world, and we provide a lot of interconnected bandwidth both for our clusters and faculty around the Purdue system. We grew back in 2004 from just 4 community cluster partners, 4 faculty members. We now serve over 200 different faculty members from almost every department, every college, and certainly every campus in the Purdue system. And so in a nutshell, that's us and where we come from. One of the big projects we do provide support for is a CMS Tier 2 site. And they actually have resources spread throughout our enterprise. So, but today's topic is about storage. And I wanted to give a quick overview of our storage hierarchies and tiers. Then I'll cover some of the differences between the file systems, and I'd like to host a discussion afterwards. Certainly there will be a lot of things I don't mention. I only have about 15 minutes, 20 minutes of slides, so certainly I will leave some out. And I hope if you have a burning question, we'll be able to discuss it later. So at Purdue, we have several tiers of storage. The first is home directories. We provide every user 25 gigabytes of backed up, snapshotted, persistent home directory space. We used to do global home directories, but we have since moved away from that. And combined, we use both GPFS and ZFS, and we have about a petabyte or so of data or of capability and all of that. It used to be a global file system, but something we've tried to do is limit the fallout. Storage is certainly one of the major categories of outages we face. And certainly when you're providing users access to thousands of cores, tens of thousands of cores, one bad usage pattern can really make everyone's day turn out bad. So we mostly have gone to per user, per resource home directories just to limit that fallout. Every resource also has a scratch file system. These tend to be RDMA parallel file systems directly attached into the clusters. An interesting side note, we were just doing some historical digging. For a long time, most of our scratch file systems couldn't even hold more than 200 terabytes of data. But today our default quota for each user is 200 terabytes. And we routinely purge that. In total, we have about 17 petabytes of scratch space in Lustre's, grid scalars, and ZFS. So I'll be using 3 different terms to describe IBM spectrum scale software. I'll use GPFS and grid scalar and spectrum scale. And I'll discuss a little bit about why I keep sort of interchanging them a little bit. Our big global file system is the Data Depot. It's about 15 petabytes. It's a global file system. So it is mounted by NFS on all of our systems. Faculty and research labs sort of buy or rent this space on a terabyte per year basis. We currently charge about $80 per terabyte year. It's composed of ArcaStream's spectrum scale support and DDN's storage software, DDN's storage hardware. The last sort of global storage service we have is Fortress. It's our multi-site HPSS tape archive. We have 2 libraries in diverse locations, and we copy data. We replicate data to both. Fortress is actually not POSIX compliant, and we don't mount it as a namespace on our machines anymore. You have to use tools like Globus or HSI and HSTAR to get your files in and out. And then finally, we have some special tiers of storage for our extremely large scale use cases. Our CMS Tier 2 site runs about 10 petabytes or so of the Hadoop distributed file system, and our cryo EM labs connect all their instruments to moosefest. So to compare sort of the file systems, when this topic came up on the CARC mailing list, BeeGFS definitely seemed like a big interest for people, as well as Lustre and spectrum scale. So they're all parallel distributed file systems. They all have multiple parts, and they can all be used to build file systems that are very, very fast and very large. BeeGFS is free as in beer. You can go download it. You can also get the source code, but it is not open source software. It was, you can actually contract with ThinkPark and various resellers for support, commercial support, which we have looked into, and we worked with Advanced HPC on several opportunities. Lustre, likewise, is a little different. It is open source, and it has a long, varied history. There are two consortiums out there that support the development, the ongoing development of Lustre, as well as there are vendors who provide support both for the open source, like they contribute to the open source version, and DDN and HPE now, with their Cray acquisition, provide vendor-specific add-ons that provide value add. Spectrum Scale from IBM is up and up, all entirely proprietary. There are various licensing models, historical ones as well as newer ones. So it is definitely proprietary software. They all have various different models of redundancy and resiliency. BeeGFS and Lustre primarily depend upon shared block devices between servers. So if one server should fail, another server will remount those bits of the file system and share them out again. BeeGFS has an interesting mode for redundancy as well, where it can do mirroring to a buddy. So writes get mirrored in two different places. And if one goes down, you still have your data available. But Spectrum Scale is very different. It has a lot of features and a lot of options. So you can do shared devices. So if you have a SAN and you have multiple NSD servers connected to that SAN, they can share the same block devices. And if one NSD, one server should die, the data is still available from the others. It also has built-in replication, both synchronous and asynchronous. So you can write multiple copies, or you can synchronize multiple copies to remote sites. And most recently, they support various types of erasure encoding. So you can plug just disks into commodity servers and then provide resiliency by sharding the data across multiple servers so it's available if there should be a failure. BeeGFS doesn't really do snapshots, at least to my knowledge. Maybe they will in the future. Whereas Lustre, the open source version, can do snapshotting if you put it on top of ZFS. Lustre has two different backends at the moment, I believe, ZFS and LDiskFS. And if you use ZFS, you can take snapshots. And I put a question mark here because if you buy some of these vendor add-ons, snapshots get better. But if you don't, there are ways to do it with the open source versions. Spectrum Scale natively supports snapshots and has for a long time. So with the storage pool line, I mostly mean, can you mix different types of media? And for BeeGFS and Lustre, you can. Actually, with all of them, you can. You can have slow disks and fast flash, and you can put files on each. But what I mean by this tiering by policy line is, does the file system help the user in any way? So with Lustre and BeeGFS, the users sort of get to choose. Do I put this data on, and admins can control this as well. Do I put my data on slow disk or fast disk? And both of those natively they will not move the files back and forth for you or for the users automatically. Now with Lustre and some of those vendor add-ons, you can add these tiering by policy sort of this functionality. Whereas with Spectrum Scale, you get it natively. GPFS has a policy engine, and you can really slice and dice where the data goes and change it. And it's sort of, if you're used to enterprise file systems, definitely GPFS has all those features. So at Purdue, we primarily focus our Lustres on DDN's exascaler. We have bought in the past open source Lustres from sort of just white box system integrators, We've also bought HP's pre-canned ZFS solution. But today, all my production lusters are exascalar, where the MDTs, the back-end disks, all sit in a sort of full-frame DDN SAN. That would be their 12Ks, 14Ks, 18Ks. They do have sort of brick-based scalable units. But it just seems to be more cost-effective when we go out to bid to buy sort of the full frame. And in the past, we've done external servers. So you get two heads and you dual path your Lustre servers to both heads. And if there's some sort of SAN failure, the data is still available. And if there's a server failure, the LUNs can be viewed by multiple machines. These days, we mostly use the embedded version of the exascalar software, and we find that it performs just as well. Back in the day, that may not have been the case, but today, certainly in the last 3 lusters we've deployed, we've just gone with the embedded version. We've been very happy with it. And almost all of our lusters are directly connected into the InfiniBand fabrics of our clusters. Sometimes we've put, and something I do like about Lustre is the LNAT functionality. We do sometimes split our clusters out into pod-based containers out in a field, and we don't like to put our storage out there. There's really not a good place to put UPSs or generators or anything like that. So we put the storage in a nice centralized data center, put the compute out a ways, and then we've used Mellanox's long-haul AV, and we were very happy with it. But a very cost-effective solution we found recently is to use 100 gigabit Ethernet for those long-haul links and LNAT routers to get the Lustre represented back on the InfiniBand fabric. We've been very happy with that. By the way, I mostly found most of these images about the architectures out on the internet, so I did not make them. Please see the links for the sources. So for spectrum scale and GPFS, there are multiple ways one can buy it. For the data depot, we went to DDN for our hardware, and then we bought servers, and we went to IBM for the GPFS software. And the first incarnation of the data depot used just straight up IBM's version of GPFS. The second version, and we've recently gone through a migration to the new version of the data depot. We partnered with ArcaStream, which is a GPFS spectrum scale OEM. They have a product called PickStore, advanced hearing feature called Ingenia that we use. And we've been very happy with that, but we've done it both ways. And almost all of our GPFS file systems that we've deployed as Scratch file systems have been DDN's grid scaler. DDN is somewhat currently, and I think this is changing, is a GPFS OEM as well. So they have 2 sort of competing file systems. And we've sort of done it all of these 3 different ways. Licensing in GPFS can be somewhat interesting. You can license it if you're a historic customer by the socket. If you're working with an OEM like Lenovo or ArcaStream, you can license it by the disk. And if you go directly to IBM and buy their integrated versions, you sort of license it by the by capacity. And there are trade-offs to all of these things. Your mileage may vary, and your experience will vary there. In BeeGFS, we do use BeeGFS at Purdue, but mostly they're beyond product, the BeeGFS on demand. They've really packaged this very nicely to just, it's just one command you can run in the epilogue or prologue of your resource manager, and you get, and every job can get its own sort of parallel file system. We've been using diskless or mostly stateless compute nodes for about 5 years now, but we still put some sort of local storage, both for swap and for beyond. Excuse me, and all of our compute nodes. And we found that users that have really metadata intense operations really find that this is attractive. The best use case was someone who wanted to work with a data set from Twitter, and you know, as the data comes, it's a big tarball, and as you extract it, it becomes 140, 108, 280 character files, and just a billion of them. And so we found that this works really well for use cases like that. We've yet to deploy it as a persistent file system, but I think someday we will. We've been very happy so far. We have one in testing. And just to sort of cover our special use cases, the CMS Tier 2 site uses the Hadoop distributed file system. No really other Hadoop services on top of it like Yarn or anything. They have about 70 servers that are all different vintages and varieties. Some have disk trays, some have internal storage. But when it's all combined, it's about 10 petabytes of data, and they have some intelligence that they've written, that the people at Purdue have written to increase replicas or decrease replicas as necessary. In Hadoop, you do have replication, so space can really disappear quickly if you don't manage it properly. And the last file system I'll talk about is moosefest. For over 10 years, our electron microscopy folks have been, they first started out using moosefest just by putting extra disks in their workstations around their lab. And that worked very well for them. They've since moved to persistent servers with embedded storage and been very happy with that. We've thought about like mounting the remote file systems on our clusters, and that's sort of fraught with security and reliability issues. But since we've connected them to the Science DMZ using 100 gigabit Ethernet into their building and using Globus to get files back and forth, and I think everyone's been very happy with that. And then a project we've also started about a year ago is we collected all of our, since we build and retire clusters on a fairly regular basis, we collected all of our spare disks. And a lot of these storage systems we have are really just SAS disk trays attached to servers or RAID heads or something like that, and we've been collecting them. And we have about 14 petabytes of replicated storage that we use for storing backups and other sort of non-production things. And we've been very happy with that. I guess one more thing, we use ZFS. With all of our other storage available to us, we still find the occasional use case where people need a petabyte or so of storage. The big first production use case of it for us was using ZFS and encryption to provide our HIPAA and our ITAR secure environments with their storage. The snapshot and replication tool for asynchronous replication have just been awesome. We've sent a slew of admins to the disruptive storage workshop. I don't believe it's held anymore, but that was just a great opportunity. As well, one of our minor clusters that does, however, have a lot of use case, has a lot of usage, is the Scholar cluster. So we support about 8,000 students per semester. Faculty will be teaching them chemistry or weather modeling on the supercomputers, as well as we've really picked up in the data science realm. Our statistics folks are definitely, they definitely needed a resource to introduce students to real data science tools. And we've backed all of that by ZFS Storage. I've been very, very happy with it, actually. So yeah, and I think this really is the last slide. I lied again, I'm sorry. So I wanted to talk just a bit about how we procure these things and go through acceptance testing. For us, we do try to bring in the lowest cost we can. Money isn't unlimited. So one way we do that is by being very proficient in multiple file systems, so that when we go out to bid, we can make very neutral requirements and really get competition going in a bidding process. Depending upon the size of a project, depends upon how much we ask the vendor to help. For Anvil, the cluster we're building with the National Science Foundation, DDN is going to help us a fair amount in that deployment, whereas all of our ZFS and moosefest and HDFS file systems are all sort of done in-house. We go out for generic, just generic servers and disk trays, and we do it all ourselves. So we sort of go on that spectrum, but I think the one thing we found, no matter what we do, is that thorough acceptance testing is really important for the production phase of a file system. And that's really to establish all of our baseline expectations. Like I said, when you give users tens of thousands of cores, a misstep can really cause a bad day. And knowing when a file system is performing as it should and when something is just really broken has been invaluable to us. Through all of our years of procuring storage, we've never had to send a file system back. Certainly we have requirements in the bid documents and we want to make sure vendors meet them. But it's been less validating that they've dotted every I and crossed every T, because we find that they usually do. We've never had a purchase go completely sideways. And I think that's because we're always prepared, as much as we can be, to run the file systems in production, which means we know how to generally set them up and run them. And that knowledge has come in handy when we've gone through procurement phases. So with that, it was my last slide, and I'd really like to take your questions and hopefully get a conversation going.
So there are a couple of questions that have already come up in the chat. Earlier, when you were covering your Lustre content, somebody had asked, probably for clarification, on your dual-homed 100 gig IB LNet routers.
Mm-hmm.
Probably curious a little bit, but maybe Andrew, if you can add clarifications, what you're curious on there.
Sure, if he doesn't have a microphone, but
oh, sorry, here. Just the architecture of the, if you for what you move, what the LNet routers look like, and any performance issues with that.
Sure. So our central data center is in the mathematical sciences building. So we put the grid scaler appliances there. Then there's just an Ethernet switch that they connect to. So the grid scaler doesn't have any InfiniBand. It just connects directly to Ethernet. And then there are some number of fibers going between the math science data center and the data center in a shipping container pods out in the field. And at the pod, there is another Ethernet switch that collects all of this bandwidth. And then the LNet routers connect to the Ethernet to get to the storage. And then they connect to the InfiniBand to provide direct RDMA into the Lustre clients in the compute nodes. The LNet routers themselves are generic white box servers. They tend to be, I think they were just whatever compute node we were buying at the time. And we don't put a lot of memory in them. But we do use separate Mellanox NICs and separate PCI Express slots to get the most bandwidth. Did that answer the question or what you were looking for?
Yeah, I think that's with the grid. Yeah, thank you.
Mm-hmm. I guess one thing I would note there is that while we do use Exascaler for the appliance, the LNet router config was done all in-house. I don't think DDN actually supports the LNet stuff, or at least for us, we've never asked them to.
With as sensitive as GPFS is to network disruptions, have you had any issues with remote? With these kind of distributed sites, are you using remote clusters to do that?
That is a great question. So the data depot was originally intended to be mounted natively on all of our compute nodes. So we'd actually install the GPFS kernel module and run the GPFS client on every compute node. And we did that for a while, but compute nodes going down, compute nodes running out of memory, which was a really big thing, and actually it was the impact that a user could have on a compute node is why we changed. We found that our network was fairly reliable, and at any time that instability was shown there, the file system recovered very well. But when a compute node just went offline and then would come back some minutes later, that just wreaked havoc on the GPFS native mounts. So today, unfortunately, and I will say that that provided, when it worked, provided obscene performance. By doing synchronous replication, our read performance was just absolutely stellar. But the stability issues were just debilitating. So we now mount the data depot through NFS. We have a number of NFS heads, and we mount it on our compute nodes with NFS. A little sad about it, but it has become infinitely more stable that way.
Alex, we've got a question here about moosefs. What are your uplink speeds of the file system? And have you encountered any issues with regard to new instruments generating so much data that the transfer rates become an issue?
With 10 gigabit links and all the servers providing moosefs, it isn't the most performant thing, but it is great for capacity. The more servers you have, the faster it goes, which is great. One Achilles heel of it, especially in the open source version of moosefs, is that the name node, or the machine that contains all the metadata and state in the file system, it can only live on one server. You do have backups that get copies of the metadata occasionally, but they're not, but you really are limited to the metadata performance and sort of meta operation performance level that one machine can provide. And this has become a problem, especially for use cases with tons of small files. That is a big bottleneck. So certainly the cryo-EM folks are just dropping lots and lots of image files, which tend to be fairly large, and so that works for them. And all of our other use cases tend to be fairly large streaming file I/O there.
Okay, next question, I think a couple people have asked this, is what's the total FTE count you have to manage all this?
Sure. Our engineering team is fairly diverse. We have 2 dedicated storage admins. One does file systems, mostly working with DDN, and then another guy does the HPSS archive. The moosefs and the Hadoop file systems are all sort of shared. So I think in total we have maybe 5 FTEs or so of people doing file system work and storage work.
Okay, next question. Do you have any pointers to ways to go through acceptance testing?
I think, besides the ones that are sort of here on the slides, other things I might suggest is working with vendors beforehand. And I think you should definitely deploy or get these vendors to help you deploy a proof of concept. Certainly deploying a proof of concept at some scale will be very difficult to do, get them to agree to, but having hands-on actual experience yourself with all the technologies that might show up in the bid has been very important for us, especially as we've opened our bidding up to more vendors with varied solutions. Knowing, because it's hard to know what you don't know. And thankfully, if you're going down the path of an open source file system or a open source file system that has vendor value add to it, you can actually deploy a lot of this yourself relatively cheaply. And I recommend doing that. Having the knowledge in hand to know specifically how to evaluate responses has been key for us. and making sure that when we do select someone, even if they are the cheapest, that we generally know where we're going with them and that we're comfortable with the vendor. So I guess those would be my tips.
Next question is, how much do you rely on Lustre support for problems and how responsive are they?
We rely upon DDN for a number of things. We, in the past, have been very reliant upon them. A lot of our Lustre proficiency has been very recent. And we find that DDN has been a great partner in the long haul. I wouldn't say that every support interaction has gone well. And I won't say that every outage has been resolved quickly, but with their acquisition of WAM Cloud recently, that has improved dramatically. With their sort of focus on bringing Lustre up to enterprise quality, that's also helped a lot. Knowing your support, not only the backend support people, but also the support project managers is important. And today, I think that our support situation with DDN is going really well. But in the past, it's been a little rocky, but they fixed it. And I think that's the important part. Certainly some other vendors we use have always been rocky, and I use them because they have features that other file systems don't. And for the use case, I just have to go with a vendor I'm not entirely comfortable with because they have the thing that does what I need.
Next question. Can you give us a cost comparison between BeeGFS and ZFS?
If you're going out and buying the hardware yourself, you have some overhead. You have to buy some management servers or a server to do the management pieces. So in that regard, if you're just going out and buying the hardware and integrating it yourself, they're very close in price. I don't know of anyone actually selling ZFS support anymore. I guess Oracle is selling ZFS support in some way, maybe. So I don't know of anyone doing ZFS support for money, but certainly BeeGFS, ThinkPark, and their resellers will provide commercial support. And that, so I guess it's free versus not free, but it can be free if you want to do the integration yourself. One thing we do, if we are doing integration ourselves, we always try to keep a replica of the data somewhere. So our major use case is the secure computing environment and the cluster for learning. And in both cases, we do asynchronous replication offsite. So, even if we trip over something and we really have a bad day, the key for us has been to have a copy of the data. Even if it's a day or a week old, people are very forgiving as long as you have something for them. And I'd like to say that we haven't had a lot of bad experiences. And because you're just buying, or we are buying white box hardware, the price is very conducive to keeping a copy somewhere else. I would definitely suggest trying all of these things in development before you take them to production, if you can.
We've got a question on quotas. Are quotas based on user and group, and are they available on all systems? And how do you manage them for thousands of users?
Yeah. So our quotas are fairly hard set per user for home directories, 25 gigs, and that's really all you get. I won't give you more. Unless you're root and you know how to set your own quota, then go for it. But of course, users don't get that ability. In our Scratch file systems, when a Scratch file system is only maybe 3 to 5 petabytes in size, giving every user 200 terabytes of quota is really just there to make sure that a runaway process doesn't fill the file system. And we find most users don't have that much data, and we purge it regularly. There are some users that have lots of data, and in that case, they just get to write into the file system. There aren't very many. It works out really well for us. We've really eliminated the need for users to file tickets after work has stopped because they've run into a quota issue. So for our home directories and our scratch spaces, it's by user. The data depot uses GPFS's file sets to do sort of directory level or file share level quotas against an entire data set. And there we have a portal that you can go to. You type in your university account number, and you say, I want 10 terabytes. And the system's like, okay, that'll be so much money this year. Is that okay? They click yes, and then the system just sets that quota for them, and then they pay. A trick for us has been the HPSS archive. Because we purge and because we charge for persistent data in the data depot, users having an area of last resort, you know, when their grant ends or they graduate or they leave a research group, they don't have to delete their data. They can put it in Fortress. It's offline data. It's on tape. It's not going to be in the cache. But they do have somewhere to put it that they don't get charged for. And I think HPSS is what makes a lot of our storage work as well as it does, because users always have that place of last resort. Everyone goes through bouts where they don't have funding, and tape is super cheap for us. So I think that has made a lot of our storage shenanigans work out. And it's unlimited. There's no quotas in Fortress, so that helps too. Well, helps the users.
Our next question is, have you ever considered Ceph?
Yeah, we have Ceph in our testing environment. We are deploying increasingly more amounts of Kubernetes, and all of our container work in that regard has been based on Ceph. In the next, I'm going to say 9 to 12 months, all of our Kubernetes work will go into production, and we'll have production Ceph. But there we're mostly using it for objects and block storage. We don't have a lot of experience with the Ceph file system. Something that I'm not quite a fan of with Ceph. I'm very much a fan of Ceph, and I've been following the project for a long time, but the server requirements, mostly around memory and processing power, are pretty steep. Most of the servers we use for HDFS or moosefest, you know, servers probably only going to have 16 to 32 gigabytes of memory. But in Ceph, you really need a lot of memory. And those have been, you know, it's been fairly expensive to source. So I'm a big fan of Ceph, but I don't have a lot of experience with that file system. But I hope to someday. It seems like great software.
The next question, how do you cover storage admin duties when one's on leave?
We like to cross-train. So all of our engineers, from people doing sort of back-end services, custom services for people, to cluster admins, to storage admins, they're all in one on-call pool of people, which is nice. There's about, you know, you're not on call very often in a year. And so we try to cross-train basic troubleshooting and you know, what are the first 5 minutes? Can you at least get over that? Identify a component that needs to be rebooted or shut off, so a failover can happen. And that's worked really well. But we still, you know, if you're a subject matter expert in Lustre, and a Lustre has really taken a digger, that's when the on-call person will call you in as a subject matter expert. I'd like to say that our on-call people don't get called a lot, but storage is definitely one of those things that when it's down, lots of people usually have to come in.
Next few questions are on HPSS. The first one is, do you refresh tape?
We do. We tend to skip every other tape generation, and then we use the old generation for one copy of data and the new tape generation for the first copy of data. Sometimes it even means so it just sort of, it's always this rolling sort of process between tape technologies. But that helps because, so we're going through this now from LTO 7 to LTO 9. LTO 9 is not out yet, but it will be soon. And, we're just rolling, our plan is just to keep rolling all of that technology forward. And it's great because you buy sort of your tape drives for a specific performance goal in mind. And then you get that, as you shift to a new tape technology, you sort of keep all that performance while just adding more. A tape migration for us, I think our last one took almost 9 months, and that was from LTO 5 to 7. So it does take a while, and I think our LTO 7 to 9 migration is going to take much more than a year. But HPSS is great. You can schedule all of those moves and do it as the system has resources to do it. So I think it's a very capital intensive thing, but it works. And HPSS is great for that.
A related question, do you have a defined life cycle or purge time for the HPSS?
For the HPSS, we don't. If you put a file into HPSS, we will never delete it. We have files that were put in there during the first year, more than 15 years ago, and we've kept them even though the users are long gone. There's an administrative area, and we move your data there and we keep it. The HPSS capacity is mostly on a hockey stick curve, which is interesting. Thanks to tape, it's mostly possible given the budgets we have. But the data from the 90s is really quite small compared to the data ingested just last year. And that's really helped us avoid having to delete or purge old data. And we definitely have users pop up who are like, hey, I was a grad student 10 years ago, and I could really use this file. Could I have it? And we're like, sure, here you go. Here's a Globus share link, and there's your data. Thanks for computing with us.
Next question, is the library a partner in your archival storage? If so, how are you working with them, or what have you experienced with regards to archival storage?
This is a fascinating topic. They don't use Fortress. We do have an institutional archive called the Purdue, PUR. I forget quite what it stands for. But that's run entirely by the libraries on separate infrastructure. So we don't actually work with the Purdue University libraries at all. We've had some conversations, but when you're holding 20 petabytes of data that's loosely categorized and tagged, it's a really big undertaking to think about what to do with it. Our strategy has just been to hope tape technology keeps doubling as it does.
Okay, I think we've covered all the questions that have come up in chat. If anybody else has questions they'd like to ask Alex, now's the time to ask. Well, if not, Alex, thanks for the talk. I thought it was really good. I hope everybody else enjoyed it. And everybody, thanks for coming. And Next month, we've got a talk on Slurm in the cloud. So we'll be sending out announcements for that in a week or two. Thanks a lot, everybody.
Thank you. Bye-bye.
Thanks.
Yeah, thanks, Alec.